Okay, system of inequalities and linear programming. In this section, we're going to see, instead of equations, we're going to use inequalities and how we can use them to solve some of the problems. So inequality means, let's say you have an equation, instead of equality sign you have inequality sign, meaning you might see this one, this one, this one, or this one. So in previous section we had equation, system of equation. For example, x plus y equal 5. Instead of x plus y equal 5, you have now x plus y equal greater or equal to 5, or one of these symbols. So whenever you see one of these symbols, that's called inequality. And if it's linear means the power of the variables, they are 1, then that's a linear inequality. So something like this. Okay, you might be able to see, instead of less than, you might be able to see less or equal, greater than or greater or equal. So if you try to find the solution of equation, you might find one solution, but for inequality there will be infinite solution. The solution set of an inequality is the set of all order pairs that make it true. Okay, the graph of an inequality represents its solution set. And how we're going to graph it, that's what we're going to cover in this section. So what do you do? First of all, replace the inequality symbol with the equal sign. So for example, let's say if you want to plot the graph of x plus y is greater or equal to 5, first of all plot the graph of x plus y equal 5. Okay, and then if you have just greater than sign or less than sign, then draw dashed line, and if you have less or equal or greater or equal sign, then draw solid line. Now after that, the graph consists of a half plane on one side. For example, let's say this is the graph, then this side is one half and this side is another half. Now you need to find out which one is the right solution for that particular inequality by picking a testing point. And wherever the testing point satisfied that inequality, that is the solution for that inequality. Okay, so what is a linear programming? You will be able to see a problem where you have constraint expressed as a linear inequality, and then you would like to optimize your function. Optimize means find the maximum or minimum value of a function, objective function. It could be, let's say, cost function or profit function under that constraint. So problem like that is called linear programming problems. Okay, so how do you solve linear programming problems? First of all, graph the inequalities. You might have more than one inequality, and find the feasible solution, meaning the solution where all the constants are true. And then after that, find the coordinates of the vertices of the region, and then find the objective function at those coordinates, and wherever that objective function is maximum at those coordinates, if the feasible solution is bounded, then that's where you get the maximum value. And wherever the objective function is minimum at those coordinates, that is your minimum value. That's how you solve the problem. Let's see a couple of examples from homework. This one, graph the inequality. So 4x minus 3y is greater than 12. So first of all, you graph 4x minus 3y. So 4x minus 3y equal 12. To plot the graph, find the 2 points. If x is 0, then y is negative 3y equal 12. Divide both sides by negative 3. So y is negative 4. So one of the point is 0 comma negative 4. Another point, if y is 0, x is 3 because you divide both sides by 4, so that will be 3. So 0 comma negative 4 and 3 comma 0. So that is these are the 2 points. Okay. So these are the 2 points I'm going to plot. 0 comma negative 4, which is here, and then 3 comma 0, which is here, and you join them. Because there is a no equality sign, so just use the dash line. And now this line is dividing the plane into 2 different parts. You need to find out which one is the right solution. So to do that, I always pick this 0, 0 as a testing point. I put this 0, 0 in the inequality. If I do that, that will be 0 greater than 12. So if I put x equal to 0 and then y equal to 0 here in the okay, so if I put x equal to 0 and then y equal to 0 here, as you can see here, 0 is greater than 12, which is the false finding. So that means 0, 0 is not the part of that solution, so it's supposed to be other half. So this plane is supposed to be the solution of this inequality. So let's choose which one is the right option. So as you can see, it's supposed to be dashes line. This is the one which is, the feasible solution for this inequality. Okay, let's go and do another problem. So x plus y is less or equal to 6. You need to plot that. So because there is a less or equal, so use the solid line and you can find the points. If x plus y equals 6, then 6, 0 and 0, 6 are the 2 points. I'm going to choose that 6, 0, which is here, and 0, 6, which is here. Okay, and another line is x minus y is less or equal to 4. So choose this one. If x is 0, y is negative 4. And if y is 0, x is positive 4. Okay, so now you also have to find out your feasible region. So this is the inequality. And I am not so sure if I have to, yes, I have to set the feasible region as well. X plus y is less or equal to 6. If I plot that graph, as you can see here, this is the graph I got. And because it's a less or equal, so if I put 0, 0, so this is the side. Okay, and another one is, let's say x minus y is less or equal to 4, which is I got when x is 0, y is negative 4, when y is 0, x is positive 4. So this is the line I got. And if I choose 0, 0 as a testing point, that's satisfied. So that's supposed to be this side. So it's supposed to be bounded by this side and this side. So this is my shaded region. So if I go back here, this is my shaded region. So I click here and then I put it here. So that is the shaded part. So that is the solution for this both inequality. And that's all. What is the vertex? How do you find the vertex? The point of intersection between these two lines, which is here, it's a 5, 1. So that's the point of intersection, 5, 1. 5, 1. That's the only one point we have, because other points you don't see the point of intersection. So that's the vertex, only one vertex you have. Okay, I think we have the same type of questions, so I think you will be able to finish all these questions. So that's all for this section.